Hey guys, welcome back. I am Pratham Modi and today we will be designing linear equation solver and I will be giving a brief introduction about adder and subtractor design. So let's start. What do you think when the circuit is said to be linear? It is said to be linear if there exists a linear relationship between the input and output. That is, the input and output should increase constantly with each other. So now we will be designing a linear equation using an opamp where my voltage output VO is given as 2VA plus 3VB minus 4VC. We are given three different values over here. So while designing we could have used 3 op amps, but as we are engineers we should make sure that minimize use of the circuit. The size of the circuit should be less. So we will be using 2 op amps. One op amp is also a bit more, but one op amp we could have been using this, but it makes the circuit gaudy, so it is better to use two op amps for this kind of circuits. So what do you think that where this linear equation can be applied? So you can use this as sign changer, scale changer, inverting amplifier. These all are linear op amps. C to V, current to voltage, voltage to frequency, integrator, differentiator. We will be looking all of these in the later videos, and the main application is electroencephalography. Electroencephalography is the main application of this equation solver. So the applications of this EEG waves are neuroscience and social interaction, neuromarketing. These kind of waves, if you have seen in hospitals, you can see these kind of waves. So these are being done with the help of this equation solver. So this VO is equal to 2VA plus 3VB minus 4VC. Let's come back to this. As the formula for inverting amplifier suggests, that VO should be minus RF by R1 into VI, that is input voltage. So let's say I will be taking my RF as 10 kilo ohms. So what should be my R1? R1 should be nothing else but 10 divided by 2, which is 5. So we will get RF as 5 kilo ohms. What should be my R2? R2 will be nothing else but 10 divided by 3 over here. So it will be 3.33. We could have easily find out this value of all the resistors used in this if we would be analyzing it, but this is a bit of a kind of a shortcut method which can be easily remembered for exams and for designing this kind of circuits. Whatever the value of RF you took, just make sure that the value of RA, that is R1, should be the reciprocal of it. So that is 10 divided by 10 into 1 upon 2, which is nothing else but 10 divided by 2, which is 5. Then 10 into 1 divided by 3, which is nothing else but 10 divided by 3. So we are first going to design the equation for this 2VA plus 3VB. So we will be using just one op amp, and then we will be cascading the minus 4VC to get the whole output. By the output of this op amp will be given to the input of the second op amp. So let's begin the design of the circuit. So this is LTspice. Over here, let's say I will be using my VA. Let's take it VA is equals to 2 volts. Okay. I will be taking VB as, let's say, how many should I take? 1 volt. Okay, 1 volt. And I will be using VC is equals to let's say 2 volts. So we will be designing this for, and let me write down the output equation as well. VO is equals to 2VA plus 3VB minus 4VC. This is our output equation, and this is the values which we will be using over here. VO is equals to 2VA plus 3VB minus 4VC. So now what do you think the output of this equation should be? Let's substitute VA as 2, VB as 1 and VC as 2 again. So 2 into 2, 4 plus 3 will give me 7. 7 minus 8 will give me minus 1. So let's begin to design. OP07 will are my two op-amps. Just make sure you design it which should be pleasing to eyes. मतलब सिर्फ डिज़ाइन करने के लिए डिज़ाइन नहीं करना चाहिए. So V1 and V2. Now we will be requiring R1 as my first one. This will be my second, and I will be giving feedback. The output will be given to this. This will be my this, and this will be my this. So let's make the connection over here. So the first connection, then we will be giving V2, that is VB. Okay, then the feedback, see dude, that designing is not a big issue over here, but the main and the biggest issue which everyone faces is that the values of the resistors, sometimes it becomes, sometimes some output are not coming properly, so we get frustrated that why and this and that. Now we will need a voltage source over here, so we will go voltage source. No, this is for V1. Okay, this is for V2. Okay, this is for my R3. Okay, and this is for my opamps. Let me for ground supply over here. So just rechecking the circuit. See, it is V2, so I can take him over here so that it is easy to understand, no overlapping, nothing. Now let's name them. This is my V1, this is my R1, this is my V2, this is my R2. So this is R2, okay, sorry. So now I am taking my RS, say 15k, and this is nothing but RF. This is my RF. Again, this is my RF. This is my R3. Sorry, there's a mistake. No. Okay. So this is where the ground terminal should be there, which I really thought that it was a mistake, but no, it's not a mistake. It is absolutely perfect. Okay, so over here I'm left to connect, and there you go, ground. So these are the connections. Let me make this R3. Okay, so now I have taken over here 15k. As I mentioned earlier, what should be my R1? R1 is 2 over here, so I have to make sure that it is 15 by 2. For simplicity, let me take a 16k. So the calculation for this and the other part becomes easy. 16 divided by 2 is 8k, so I will write over here as 8k. What is 16 divided by 3? It is something 5.333, 5.33k, the reciprocal of it. Now what I have to do over here is, this will be my 16k, but RF and R4, we should always make sure that it is unity, which is equals to 1. So I will write over here as 16k. Okay, and what will be my R3? It will be 16 divided by 4, which is 4k. Now for powering up an opamp, 15 plus 15 minus 15, no need to write minus 15 because we will be designing over here, we will be writing label net, we will do it. So this is my VCC, this will be our VEE. I will change that, but before that let's just finish enabling all the components. VEE, this will be again VEE, and also this as VEE. Again I have missed a ground terminal over here. These are the small errors which we make, which don't result in a proper output. So now what should be the value of V1? I will make this as VA. Chalo, let's make this as VA, as we have taken VA, VB and VC, right? So let me make this as VA, VB and VC. No need to do any changes over here, it's okay. What is my VA? VA is 2 volts, so this will be 2 volts. What is my VB is 1 volt. Sorry, 1 volt. अरे ये क्या हो गया? 1 volt. Okay, so 2 1 and 2 volts. Over here also 2 volts. So I think I am done with the circuit. So let us rename it. Nothing to rename over here, only this is left labeling, which is our Vout. VO is my Vout. So that's it, we are done. Yeah, we are done. So now let's go to simulate, run. Over here we need DC output. Over here we don't need transient or AC analysis, we need DC output. So it will be my DC output. Name RF. Okay, so we can't use 2 RF at one time, so let me rename this as R5. This should not give me any sort of an error. Now let me run. Yes, so if you see this, what is my VO? It is 0.999172, which is nothing else but minus 0.99, which is equal to minus 1. So here we get minus 998.17234 millivolts, which is equals to nothing else but minus 1 volt. So what if we would like to see the picture over here? We can go and click VO, and over here, there we go, minus 998.17234 millivolts. Now what if we would like to remove this dot? Go to view, mark unconnected pins. Yeah, there we go. So this is linear equation solver. We can do this by taking some different values for VA. So let's take VA as say 1 volt. This as 1 volt. VB, let it be as 1 volt, and I will take this as 1 volt again. VC. So 1 1 1. So 2 plus 3 5. 5 minus 4 1. Now the answer should be plus 1 volt, not minus 1 volt. So I would again run. Yeah, 1.00183. So this is the output. Yeah, there we go, minus 1 point. So let's move this. You can move this not anywhere, just make sure it is nearer to VO. So there we go, the output is 1001827 volts. So this is the design of a linear equation solver. Now I will be describing in brief about adder and subtractor. So let's go to I have already prepared the schematics for both. I will be explaining them, both of them, in depth. So I have subtractor over here. Okay, so this is my subtractor circuit. V1 minus V2 is equals to V out, that we all know. So this is a circuit. Now I would like to run this. Over here nothing matters about the value of resistors, just we have to make sure that it has a unity gain that is equal to 1. So I go to simulate, run. 5 minus 3 is equals to 2, and there I get VO is 1.999, which is nothing else but 2 volts. So now over here just make sure that it is VVO. Just do one thing, just right click on this value. Default it will be set as default dollar sign. Just delete it out and make sure that you select voltage output. So this is the circuit for subtractor. Now let's go to adder circuit. This is my adder circuit. Non-inverting adder. This is my non-inverting adder because it has been connected to a non-inverting terminal of an op-amp. So again, making sure the values of resistors are equal to infinity. Equal to unity. And these are my 3 plus 2 plus 4, which will give me the value as 9. So let's check it out. Does this give me as 9 or not? Run, and there you go, 8.999, which is equals to 9. So now let me change this value. I would like to change the value and show you 1 volt minus 1, and let me take this as minus 5 volts. Now we would run. So 1 minus 1 is equals to 0 minus 5 minus 5. What should be my output? Minus 5, 4.9998. There we go, we get minus 5 as my output. So this is all about adder and subtractor and linear equation solver. I will be designing the whole circuit in the coming weeks for adder and subtractor. Till then, thank you so much. Thank you so much.